Okay, good morning. Today we're going to be looking at manipulating text. So it's part of data manipulation in R. So today we're going to be working with data sets from a competition on recommendation engine for comedies. So I shared the data sets with you yesterday. So today I'm going to I've extracted the data. So I'm going to use the train data, the data set. That is the file named train.csv. So I'll employ you to extract it and get it into our studio. We've done a class on this last month. So now I have my train.csv here in our studio. I've created a project. The project name is data manipulation dash strings. So we're going to be manipulating strings today for this class. So first we need to load our library, the library we're going to be using today. So it's going to be tidyverse. So I'll go ahead and load the library now into our studio. So I'll put a comment there. So type in library and tidyverse. So press down Control Enter, or you click your run on the line while on the line here. Okay, now I have my tidyverse loaded. So I'm going to bring in the data, that's the train.csv, the data set that is available in the train.csv file. So I'll go down now. So it's going to be, I'm importing the data. So data. So here it's going to be, I'll bring it in by using the function read_csv. So put in the data, that will be, so I'll save that as comedy underscore train underscore table. I'll assign this to it. So now I have my data set saved into our studio as comedy underscore train underscore table. So if I go to the environment, so I'll see it's there. It's now available for me to work with. So we can have a tabular view of the data set by clicking on it, on the name in the environment section, the tab. So it brings it out. So now we have variables as viewers underscore ID, joke on identifier, response ID, and the rating. So before we continue, I would like to save my file so that I don't lose anything here. So I'll save it as string manipulation. Okay, so we'll move on. So the next thing we're going to be looking at is, I shared a file with you on stringr cheat sheets. This is available in our studio website. So I've shared that with us before this class. So we're going to be looking at the documents to guide us through this class. So I'll share that with you. Yeah. So do you have something like this? Okay, good. So we can continue. So I'll go back to the R studio. So the first thing we're going to be looking at is str, that's string underscore detect. So if you want to get more information about any function you're using within a package, all you just need to do is go to your console, put in the question mark str underscore detect, click enter, then you get more information within the help tab. So here you can see the description here will detect the presence or absence of a pattern in a string. So I'll start with an example here. So I'll go back to the data set that we're working with. I want to take something from the joke identifier. So I'm going to take one of the values there. So I'm passing that in here. So I want to detect a pattern. So it's going to be, so pattern, so I can put something like cleaned the, so I want to detect if there is any pattern like this, cleaned the. So I'll just run this line to see the output I will get. So the output that is going to be returned, it's a Boolean. A Boolean in the sense that is either true or false. Is this pattern present or not? We can decide to go ahead and change this and put something like Ali Baba. So if we run this line of code, it's going to give us, it's returning back false. So that's the what this functionality does. So we're detecting a certain pattern. It can be anything that is similar to what we have there or not similar. So it gives you true or false. So I can change this as well and put something like clean. So it's still true because that pattern is available in the text that has been passed in as the string. So let's move on now. So right now you can also use this within your data set. Like you can use it to look at a certain variable within your data set. So let's try and see what we can achieve by passing in underscore detect. So I want to pass in the variable okay. Okay. Okay, somebody is asking if it's case the functions are case sensitive. Yes, the functions are case sensitive. You have to type the functions like this. But if it is the string that we're passing in, it's looking for something similar. Let's put in something like this. You can see it's you need to have it as the same case because we are matching, we're kind of comparing what you have in your variable to what. Okay, good. So we can continue now. So we're trying to compare what we have in the string and the pattern. So it has to be the same thing. So it has to be a capital letter K and not a small letter k. But for the functions, they are to be typed the way we have it here. It cannot be capital letter. So let's move on. Now I want to pass in, they call me that will be. So I'm passing, I want to use the same pattern. Okay, so if we click Control Enter to run this, you can see what we have now is just a a bunch of true or false, true, false, true, false, true, false. So this goes a long way to help us when we are manipulating our data in preparation for maybe a machine learning project. We want to prepare our data for the model that we're going to be using. So these are some of the things that can, functions that can help a lot. So from this one, we can look at something like creating a flag. Like maybe we'll create something like another variable where we're trying to detect is Clint within this joke identifier or not. So I want to do something like the okay comedy. So I want to mute it and create a new variable. Clint. Okay. So here I want to create a new variable that's going to be added to my comedy underscore train underscore table. So I'm going to give it the name Clint the drunk. Okay. So it's going to save true or false into the variable. So let's try and run this. So if we look up now, you can see what we have here. Now we have trues, bunch of trues or false here. So the name is being kind of so being kind of truncated. So let me put it back into the Control C. So I'm adding it directly to the data sets. Now we should let me see. Okay, sorry. Okay, we should be using equal to here. So I'll run that again. So now we have it here. Okay. So this is just an example of what we're trying to achieve. So here we have trues and false and trues and false. So here we can change it to a numeric value. So this can help, it will help us to have the values in a format that is much more likened to the machine learning model. So I can say control. So I can convert it to numeric. So let's try that. I'll run that line of code again. So you can see now we have bunch of ones and zeros. So these are some of the ways that you can manipulate your data so that we would, like the joke identifier now is having so many data, so many values that are different, but they've been combined. So we have the comedian's name and the city where he performed for that event and the version of the event. So this, for us to make sense and prepare our data well for machine learning model, you can decide to split that by making sense of the values that are within it. So if you want to create a variable like that, this is how you go about doing that, by using the detect function. So let's move on. So the next function we're going to be looking at is going to be str, that's string underscore count. So this is going to tell us the number of times that the pattern is true. So it's going to give us the number of times that the pattern occurred and it's true. So let's give another example. I'll copy the same thing here and I'll pass it into the function. Then I'll run that. So you can see now it's available. Clint is available only once within this string. So if I change it to something like Clint, now we have Clint twice in the string. So we'll run it again. So it's now changed to twice. So that's what this function does. So another thing that we can do with the string counts that you can make sense of or try to be explore more, you can count the number of times that the pattern was true. You can use, maybe we'll pass this function into the sum function. Let me copy this. Control C. So we can say sum. Then we'll pass the whole function into it because it's going to return numeric to us. It's going to be 1 per each row, each observation within our within the variable. So I'm going to change this to, I'm changing this to the variable name, joke identifier. Okay, we'll be taking a break in the next 10 minutes so that we can allow others to join as well. So I'm passing in the variable again. So I'm passing in the joke identifier variable. So I want to count the number of times that Clint occurs within the variable. So I want to know the number of observations that has Clint within it, the pattern Clint within it. So this, now I'll run this line. So we can see what we are is returning 201,041 of number of observations that has Clint within it. So this can help us in knowing the number of events where Clint the drunk performed based on the data that we're having. So here it's representing Clint in so many ways. Clint is here in Enugu, Clint is in Port Harcourt, that's PH, as well as Lagos. So all these are summed up together. That means he was available in 201,041 events within these data sets. So that's some of the ways that you can make sense of this function as well. So let's go ahead now. So the next thing I want to look at is, use the function str_which. This is going to return the index of each of the observations where Clint, the pattern Clint, is available. So all I just need to do here, we'll copy the same value for the function. I'll send it in here. So here I want to know the index, the number representing each observation or rows where Clint is available, if the pattern Clint is true. So I'll run this line. So here, so this is what is returned to me. You can see what we're having here is 993, 94, 95, 96, 97, 8, 99, 100. So this is 1,000 records, that's indices that has been returned, and you can see the remaining omitted observations 200,041. So that means if we had the 1,000, we have our 201,000 observations that were having Clint in it, just like we detected using the sum variable. So here we have all the index of the values that we have Clint found inside each of the values. So we have 1, 2, 3, 4, 5, 6, 7, 8. You can see 9, 10, up to 24 has been omitted, is not there. That means Clint is not available there. So here we have all the indices for all the observations where Clint pattern was found. So let's look at another, the next function that I'm going to look at is str underscore locate. So I'll use another example here, a simpler one before we go into. So here would, so if we run that line, we'll get in something. That's the first occurrence of that pattern. It's been returned to us. It's giving me the position where Clint, that's the K starts. If you look back, if you look up here in the script, K is represented as 1. Then the next alphabet is L, I, N, T. That's 5 letters. That means it's ending at the letter T. So if I change it, if I change the pattern to Clint the, so like this, I've changed it from Clint to Clint the. So let's run that again. So it's now showing me. So now here, you can see Clint is repeated twice. Okay, so it's going to start from the first letter, that's the K for the first Clint, up to where it found the DE. So that's why we're having a total of the position for the last letter is 14. So 5, the letter for the Clint sum up to 5, then the space, then another Clint, another Clint, then space, that's 12, then D, E, making 14. So here, the second one that is referring to, that would be from the second K. So, but if we're using the second version of locate, that's locate all, it's going to be a different scenario here. It's going to be a different output. Control C. So let me take out one of the Clints to remove the confusion here. So here I'll run the first one. So here, for the first one, let's compare this. Control C. So if you look back, I'm trying to run this line, that's str locate. Once again, I'm trying to run it again with 2 occurrences of Clint the and Clint the again, Clint DE. So we have 2 occurrences of this pattern. But what string str underscore locate does is this. It's only return an output based on the first occurrence. But str underscore locate underscore all returns all occurrences that it comes across. So that's why if we rerun this line of code, it's giving me two lists, or a list of the two occurrences. That's the starting position and the end position for the first occurrence. That's 1 to 8. Then the second one is from 10 to 17. So I hope we're clear on this. Are we clear on this? Okay. So we can go ahead. So we have 1 minute left for me to take a break so that we can conclude on this recording for this class. So for all the functions that we've used within this session, there are different ways. We're going to come at the end of the class, we're going to use it for the whole data set. So we'll return back in the next, let's say 5 minutes. We'll come back, we'll log in back in the next 5 minutes. Thank you so much.